Okay, so let's get this started. Thank you everyone for joining. Um, my name is Zvonimir, and I'm a professor here in the School of Computing, and I'll be co-teaching CS2100 this semester with my colleague, Professor Bay Phillips. And so this is going to be our first recitation. They will all be delivered through Zoom. Know that I'm also live streaming this to YouTube, and later on we will make this available as a YouTube video as well. So you can go back to it and revisit it if you want to, or if you miss one. So what we'll go over today, we'll go over the syllabus, kind of revisit some of the things from the lecture that you hopefully have watched. And then we'll try, if there's time, we'll see how far we'll go. We'll solve some problems on number sequences and logic. So that's the plan for today. Before we go to the syllabus, I just want to cover some things about these Zoom meetings. You'll be joining a lot of these. So first, please make sure that you're muted when you join the meeting. You know, we'll have like around 50, 60 participants in these meetings. And if you're not muted, then background noise kind of bleeds into the meeting and creates problems for everybody. Another thing, I would appreciate if you would turn on your camera if you can. You know, we will not be enforcing this, but it's kind of nice to see faces on the other side when I'm delivering these lectures that I was just talking to a blank screen. So I would appreciate this. And then finally, so how to ask questions during this recitation and discussion sections. So please do not just unmute yourself and start talking. This will lead to confusion because you guys cannot see each other and so on. So instead, there'll be a TA who will join each recitation discussion section, whose only task is to monitor the chat and raise hands and so on for the questions. So the two ways that you can ask a question, the first one is to use the raise hand feature in Zoom to indicate you would like to ask a question, and then wait until TA unmutes you, and then you can ask your question. And I will periodically pause and ask if there are any questions. And the second way is that you can ask your questions by writing them in the Zoom chat. And again, when I pause, the TA who monitors this chat will relay these questions to me. And so the TA that joined for this recitation session is Lynn, and she's monitoring the chat and so on. So that's how Zoom meetings are going to work. Any questions so far? Okay. Okay. So what are we going to cover this semester? So CS2100, the kind of big high-level topics are Boolean logic and proofs. We already started with Boolean logic. And then we'll move on to sets, functions, and relations. We'll also do counting and probabilities, and we'll wrap up with graphs. And then a big topic that you will see over and over again in all of these chapters is doing proofs. So we'll do proofs about all of these concepts. So that will be this semester for us. So in the lecture, I already mentioned a number of things why I think CS2100 is important. And I wanted to add one more to the pile. If you've ever, interviewed with, Google or Amazon or one of these companies, you know that you get this sometimes tricky interview questions that you kind of have to study for. And some of the examples of questions that come up over and over again that are related to the material in CS2100 are things such as, how would you flip all odd bits of a number? So that's related to propositional logic. Or how would you find the next multiple of 64? Or questions related to probabilities and counting. In this case, I have these examples with pairs of socks. So I think that's yet another reason to really study this CS2100 material, because it does help you to prepare for interviews later on. Okay, so instead of having slides about the syllabus, I'm actually going to walk you through our syllabus on Canvas, so that you familiarize yourself with the structure of the Canvas page and the syllabus and so on. So it's really easy to find it on Canvas. You should all make sure that you thoroughly read it to understand the details of the course and so on. And so, you know, the first we list the instructors and so on. There are 2 instructors. It's me and Professor Phillips. We have 6 teaching assistants that will be helping with the course. One thing that we already mentioned, the lectures, the pace of this course is fairly fast. So make sure to stay on top of the material. Make sure to do a lot of practice problems, because it will help you to identify what you don't know or what you struggle with. And when you notice that you struggle with something and you don't really understand how something, you know, is working, make sure to ask for help. And I'll talk a little bit more about that as well. But the general message is do not fall behind. The material does kind of build on top of each other. So, you know, it's kind of hard to understand, you know, functions if you don't understand sets and so on. Okay, so what does this course consist of? We have online lectures. Hopefully you already watched the first 2. The first week was a little bit weird because it's the first week, but in general, we will try to post the online lectures by Wednesday, by let's say Tuesday night, Wednesday morning for the following week. So the online lectures for week 2, we will post them later today. And then you have almost the whole week to watch them before the recitations next Tuesday. So, okay, we have this recitation on Tuesday. You just join for one. We'll have Thursday discussion sessions that will be led by TAs, and they'll be solving problems in a Zoom meeting. And then a really important thing are the dates for quizzes and the final exam. So you cannot miss these. And so make sure to put them in your calendars, put reminders, like make sure to note them somehow. We will, of course, announce them closer to the date as well. So make sure that you are getting Canvas announcements. So there'll be 5 quizzes. I'll talk more about this later. You can drop the lowest grade. And the way we're going to do them, everything is going to be online. You have a window between 7:30 a.m. and 4 p.m. on the day of the quiz to start your quiz and finish your quiz. And then you have 1 hour window to actually work on the quiz. So you can pick when you want to start. Once you open the quiz, the time starts. And then you have 1 hour to submit it. And note that you cannot pause it. So you cannot work for like 25 minutes and then pause it and then come back and work another 20 minutes and so on. Once you start, you have an hour. Latest time you should start is 3 p.m. And in this link, general rules for exams, we describe the process. Okay, any questions so far? Okay. In terms of course materials, we have this website. Make yourself familiar with it. I'll show kind of the key elements later on. There is a textbook that you have to do readings from, and there is lots of exercise problems there that are very useful. We'll be posting videos of lectures, as well as recitations and discussions. And we will also be posting course notes in the form of slides with annotations and so on of every lecture and every recitation and every discussion. And all of these are going to be linked for Canvas. In terms of student evaluation, there will be these 5 in-class quizzes, and that will contribute to a bulk of your grade. So these quizzes are really important. Then there is the final exam on December 10th. You have to be available between 3:30 and 5:30. So the final exam is going to be 2 hours. We will have short pre-lecture Canvas quizzes just to revisit the material that you watched in the lectures. So those you can usually solve in like 10-15 minutes. They're fairly easy. And then we will have homework assignments. There'll be 7 of them throughout the semester. And we also describe how to submit those and so on. In terms of grading policy, so 5 quizzes are worth 60%. We drop the lowest grade. So it's 4 out of 5 for 60%. Then we have the small pre-lecture Canvas quizzes are worth 10%. We drop the lowest 2. There'll be 7 homework assignments that are worth another 10%. We drop the lowest homework assignment. And the final exam is worth 20%. So that will constitute your final grade. One thing I want to stress out is that while homework assignments are not worth a lot in terms of percentage, they're worth like 10% in the end. They're really important to work on, to practice for the in-class quizzes, which are actually worth a lot. So we do notice that there is a pretty big correlation between how well people do on quizzes and how much time and effort they invest into solving homework assignments. So, because the questions in the quizzes are often kind of similar to questions in the homeworks, they're definitely, the concepts are the same and so on. So, if you study well for homework assignments and you do them on your own and so on, typically you do well in quizzes as well. So I strongly suggest that you, be serious about homework assignments and invest a lot of time to work on them. Any questions so far? Okay. So getting help. Read this webpage on your own. The main thing I want to stress out here is that we do have a bunch of office hours available throughout the week. So office hours are the time when you can get one-on-one help in a Zoom meeting with either a TA or one of the professors. And here is the schedule for the office hours. And there is the Zoom link. So you can join at any of these times to ask for help about homeworks or if you're struggling with a problem and so on. If you cannot, because of other classes or whatever, you cannot join any of these office hours, please message us and we'll try to maybe shuffle things around and so that you can actually join. So leverage this and don't wait until the deadline to actually do it. As soon as you notice that you run into problems, come for office hours. Okay, towards the end, we have various policies and guidelines. I talked a lot about cheating in my online lecture. So make sure to watch it to understand what constitutes cheating. The key thing to remember is that, if we catch you cheating, you will fail the whole course. So you won't just get 0 points on a quiz or something like that. You will just automatically fail the whole course. So please don't cheat. So this is our inclusivity policy. Please go through this. And so I think, let me see if there is anything else I wanted to cover. So this is syllabus. Another thing I wanted to show you, if you go under modules, this is where you can see the outline and the structure of the course as we are moving through weeks in the semester. So first, we have a couple of important pages for you to read. How to get help, which I showed you, important online links for Zoom and YouTube, how we're going to grade homework and how to submit it, and the same for exams. So please read all of these pages. They're always going to be available, but make sure to read it. And also do read the syllabus. Don't just rely on this quick walkthrough. Block an hour or two this week and go through the syllabus in detail and ask us if you have any questions about it. And now for each week, under modules, you will be able to find all the links related to that week with all the slides and videos and so on. You will find posted homeworks and quizzes. And so what we kind of learned in spring, once we switched to online teaching, one of the biggest problems the students struggle with is that, I guess because there are no in-person lectures, you don't come to campus, you kind of lose track of structure of the semester. You lose track of deadlines and so on. People were missing, final exams and stuff like that. So make sure that doesn't happen. So, stay on top of things, create calendars, create reminders, create structure so that you are kind of in tune with how the class is progressing. And these modules, I think, really helps with this. And the most important thing that we will do every week is that in the beginning of the week, we'll post a to-do list for the following week. So this is the to-do list for week 1. So it outlines everything you have to do this week, basically. And so we will try to post this week, this list, probably by Friday night, kind of the weekend before the week starts. And so over the weekend or Monday morning, the first thing you should do is open the to-do list for that week. Go through the to-do list, make sure you understand what you have to do that week. That will help you to not miss anything. So, I will not make announcements about this every week. You should just make sure that you do this on your own. So go on the modules, find the to-do list for the current week, and that will help you to stay on top of things. Okay. It's time for questions now. Do you have any questions about the syllabus, exams, anything else related to that part of the course, or actually anything in general?
Oh, someone has a question.
Vivek, please unmute yourself and feel free to ask a question. Thank you, Lynn.
Yeah, so are we allowed to attend like a recitation or a discussion for that matter at a different time than the one we are assigned, either one time
yes.
or?
Great question. Yes, so all of the recitations and discussions, all of the streams are public and so on. All of the Zoom links, are published, and so feel free to join whichever one you want. We are not going to keep track of whether you are joining the one you signed up for and so on. So yeah, you are more than welcome to do that. Another thing I wanted to mention is that, they will all look, all recitations and all discussions in a given day, we will cover the same material. Of course, a different instructor might cover it a little bit differently, depending on the questions. Somebody might run out of time sooner than the other person and so on, but we will try hard to cover the same material across all of them. And so it won't make a difference which one you are joining. And another thing, coming back to quizzes, on the day of the quiz, so they're all scheduled on Tuesdays, we will not have recitations on that day. So the only thing you have to do is quizzes. That's a great question, Vivek. Any other questions?
Do you know what happened to the first pre-lecture quiz? Or is there just like a typo of some sort? Because I never saw quiz one.
Yeah, that's a great question. I got the same question in the previous recitation. Yeah, it's not a typo. We try to, I mean, it's confusing. So basically, the pre-lecture quiz numbers I tied to weeks. And so, because, you know, this is the first week, we're not going to give you a quiz before we even see you guys. And therefore, there is basically no pre-lecture, pre-first lecture quiz. And then starting, that's why the first week is a little bit odd, but starting with, you know, next week, you know, for the second week, it's number 2, for the third week, it's number 3, and so on. So, you know, we didn't lose it, and I should make an announcement about that. It's just the way that first week works, we start with 2. Great question. Any other questions? Let me see. So there is a follow-up on Vivek's question. So Kelly's asking, if you're signed up for a discussion section that is in person, joining one of the Zoom discussions for that week is an adequate substitute. Oh, there is nothing in person. So I know that there has been some confusion about that. And, you know, this is not because of us. I mean, the way COVID news were coming in and the way the situation was changing, things keep, okay, that's for the other class. That's fine. Now that I started talking about it, I'll finish it. The way COVID situation was changing, our schedule was changing as well. And so over the summer, we had a couple of updates to the schedule. So initially, we were supposed to have, you know, in-person recitations and discussions and so on. But I think sometime in kind of beginning of July, I think everything got switched to online. So now everything related to this course is online, exams, everything, nothing is in person. Any other questions? Okay. It's funny. Brittany just messaged that one of the links doesn't work related to for help on the homework assignment. And I was actually checking all these links 2 days ago, and I thought they were all working, but I'll double check this. So I'll double check the link and I'll make an announcement. I'll fix it if it's not working. Thank you for reporting this. Oh. It seems that it's working for some people, but not for others. I'll still double check the link. So, okay, Anthony is asking, there's confusion about the quiz, what the weekly quizzes will cover. Okay, so a question about this pre-class quizzes. Okay, so first of all, there's 2 types of quizzes. There is in-class quizzes, there is 5 of them. Those are the big kahunas. They're like 60% of your grade. So those are exams basically. And then before every recitation, so then we have pre-class quizzes. So those are kind of little short quizzes, kind of 10, 15 minutes, administered through Canvas that kind of force you to revisit the lectures that you watched. So, you know, you watch slides for the lectures for the following week. You watch videos of the lectures for the following week, And then once you do that, you open the pre-class quiz, and it kind of helps you to revisit this material. So it's just kind of quick, short quizzes in Canvas with very basic questions about the material we're going to cover in a given week. So you're supposed to do those before the recitations. And it helps you to revisit the lecture videos and also to prepare for presentations. So can we use a cheat sheet for the final only, or the 5 quizzes also? I believe the answer is for the final only, but I will double check this. I don't want to say the wrong thing, and I'll make an announcement about this. Good question. Any other questions? So Hale is asking, will I be teaching this video section, or is there going to be a different instructor here or something? So I will always be, unless I get sick or something like that, get COVID, I will always be teaching the first 2 Tuesday sections. So the one at 10:45 and the one at 11:50, which is this one. I will be teaching the whole semester. And then Professor Phillips will be teaching the other 2 Tuesday recitations. And then TAs will be teaching discussions on Thursdays. So that's how it's going to work. Any other questions? Okay, there is a question from Camille about the textbook. Is the text of the library? And I still don't have my book, and I believe I need it for the homework. Usually, library does have some of the books. For the homework, let me check. I believe this semester the goal was to kind of write down all the questions so you don't have to look for them in the textbook. If that's not the case, I'll make sure that you can do homework 1 even without the textbook. So let me look into that.
So yeah, I'm actually in a similar situation to Camille.
Yeah.
I don't have my textbook arriving until later also. Do you know if the online legal scanned PDFs contain everything I need while I'm waiting?
So online PDFs, what do you mean by that? So one thing that I used to do in the past, and I will do this semester as well, I already have maybe first chapter or first 2 chapters scanned. So I will just post that on Canvas. So if you're waiting for the book, another week or 2 or 3, you can just look up the PDF that I'll post on Canvas.
Okay, thank you.
So I think that will help.
Professor, there is another question before Camily's question in the chat.
Oh, okay. Sorry, I missed it. Okay, the question is, are recitations more like lectures and discussions are more like practicing what we've learned with TAs? Okay. So we are going to be solving a lot of problems during recitations as well. So the way recitations are going to work, the first one is a little bit weird because I wanted to spend a lot of time covering the syllabus because I find that to be really important, especially now that we are online, to show the structure of the course and so on. But going forward in the recitations, usually we'll spend kind of 10-15 minutes revisiting the basics that were covered in the online lecture videos. And then we'll spend the rest solving problems. And later on, we'll try to do it together and so on. So even when I teach this class in person, usually we teach it as a flipped classroom class, which means that even if this was in person, you would have to watch the videos covering the basics. And then during in-person lectures, we will spend a lot of time solving problems. Because solving problems is the way you learn this material the best. And so we'll try to do a lot of problem solving. So this is how recitations are going to look like. Discussions on Thursdays, there is not going to be this intro about the basics. So basically it's going to be all about problem solving. But so Tuesdays and Thursdays, there's going to be, they're going to look pretty similar. And that's just the nature of this course. You want to do a lot of problem solving. And so we are going to do a lot of that both on Tuesdays and Thursdays. Okay, any other questions? Okay, so let's solve some problems. We are running a little bit behind, but that's okay. This was really important. So let me share my slides again. Let me close my chat. Okay, let me set my pen. Okay, so I have a couple of problems that I wanted to work with you guys on. We have around 20 minutes. So let's do the sequence one. Why not? So we solved a couple of these in the lectures, right? So in this case, we are given the closed formula for the sequence. And there is two parts of this question. First, what are the first 5 terms of the sequence? And second, what is the recursive formula for the sequence? And if you recall, a recursive formula for a sequence is a formula where you describe the nth term by referring to previous terms in the sequence. And a closed formula is the one we see there, where each term is described only in relation to its position in the sequence. Okay, so let's try to work on this. So what are the first 5 terms of the sequence? Well, you have to compute them from the closed formula by plugging in, index starting with 1 instead of n. So let's try to do this. So we have a of 1 is equal to, we plug 1 instead of n, 2 to the power of 2 times 1 minus 1 minus 1. So that's equal to 2 to the power of 1 minus 1. That's equal to 1. Let me bring up my notes. Okay, so that's the first term in the sequence. Then we can compute a of 2 in a similar way. So it's 2 to the power of 2 times n is 2 now, minus 1 minus 1. That's equal to 2 to the power of 3 minus 1. That's equal to 8 minus 1, which is equal to 7. And then a3 is equal to 2 to the power of 2 times 3 minus 1, which is equal to 31. A4, I won't go through all the mathematics. So, what is kind of important here is to know the powers of 2. And we'll do a lot of powers of 2 throughout this semester. So, try to memorize them. It kind of helps. Or, as a help, you can write down the sequence of powers like 2, 4, 8, 16, 32, 64, and so on. So A of 4 is then equal to 127. And A of 5 is equal to 511. So the first 5 elements of our sequence are 1, 7, 31, 127, 511, and so on. Okay, so that's the answer to part A of this question. Now we have part B. So what is the recursive formula? In this case, there are actually 2 different ways to approach this problem. One is that we already did in the lectures. So you want to find some kind of pattern in this sequence that relates the next element with the following ones. The closed formula gives us a little bit of a hint. We have some kind of powers of 2 here. So maybe they are kind of related. If you multiply the previous one by 2 or by 4, by 8, something like that, that gives you a hint to kind of what to look for. Don't forget, when it comes to recursive formula, you always need to initialize it. So this is what people often forget. A of 1 is 1. That's our initialization of recursive formula. And then we want to write A of n. And in this case, so how is 7 related to 1? So if we multiply 1 by 4, we get 4 plus 3 is 7. 4 times 7 is 28 plus 3, 31. 4 times 31 is 124 plus 3, 127. So A of n is going to be 4 times A of n minus 1 plus 3. So that's our solution to part B of this question. Know that, this, you should definitely practice sequences a lot. They come up later in the course as well. And spotting these sorts of kind of patterns, it takes some practice. And there are some common ones that kind of appear over and over again. So, A of n is equal to, let's say, x times A of n minus 1 plus y. It's a pretty common pattern. So it's, it's really worth practicing this to be able to spot these patterns quickly. So there is another way that you can try to derive this from a closed formula. And I'm going to write it down.
Professor, here is the question.
Okay. Hi, Anthony. Yeah, please ask your question.
So, like, if there's any possible that the n be 0, or the n must be 1 in every case?
Yeah, throughout the semester, we'll typically start counting from 1 sequences, yes. If we make an exception, we are going to specifically note that. Good question. So let me just finish my trail of thought. So another way to try to derive the recursive formula is by starting with the closed formula, and then you write the closed formula for n minus 1, and you try to get to A of n from there. It involves some kind of, mathematical rewrites and so on to do that, but that's another way of doing it. Any questions about this problem?
Professor, there is a question from the chat. Are we allowed to discuss homework problem with TAs or just concepts?
So you are, I mean, when you come to office hours, yeah, you can discuss homework problems with TAs. Of course, I think I already mentioned this. If not, I'll say it again. You have to come to office hours prepared with questions or partial solutions, or maybe a wrong solution to show where you got stuck and so on. So TAs are not be kind of hand-holding you and walking you through all the homework questions and kind of solving them with you. What we want to see it during office hours is that you show up with a sheet with a partially solved problem and you're stuck somewhere and you show this to TA and TA kind of helps you to get unstuck. They will not be solving the problems for you completely. They'll just kind of help you to move forward, but they won't be solving the problems for you. I hope this answers the question.
Yeah, there is another question. Can we initialize based on A0?
Yeah, so that was kind of related to Anthony's question. Typically throughout the semester, we will always be starting sequences with A1. Later on, that might change, and we will specifically note, okay, well now this sequence we're going to start with A0, but typically you should always start with A1. So with index 1. Any other questions?
You talked about how you could derive the recursive formula by like another way. Could you show an example of that?
Yeah, okay, let me I wanted let me at least outline what I mean by that. So well, you have to express A of n in terms of the previous ones. So you wanna where do I write this? Let me see what is I need more space. Okay, let me write it here. So basically you have A of n minus 1 is equal to 2 to the power of 2 times n minus 1 minus 1 minus 1. So that's based on the closed formula, this is how A of n minus 1 looks like, n minus 1. And now we have A of n is equal to 2 to the power of 2n minus 1 minus 1. So you have to rewrite now this right-hand side to somehow match what you have here for A of n minus 1, so that you can plug A of n minus 1 in. So that's your goal. And now this requires, kind of some thinking for how to do this. So the way, you kind of want to see this 2 times n minus 1 here instead of 2 times n. And so the way you do this is kind of step by step. You do 4 times 2, 2n minus 2 minus 1 minus 1. So this is equivalent to this. How did I get that? Well, you have to remember a little bit how powers work and the rules for exponents and so on, right? And I'm just going to put an arrow here. You can kind of continue doing this. And eventually you are going to get something like 4 times 2 to the power of 2 n minus 1 minus 1 minus 1 plus 3. And then this is equal to A of n minus 1. So you get is equal to 4 times A of n minus 1 plus 3. And that's our recursive form. I'm actually glad you asked this, because these rules for exponents and so on, you should know them for this course, because they will appear over and over again. And so what is happening in this step? So 4 is equal to 2 to the power of 2. So you have 2 to the power of 2 times 2 to 2n minus 2 minus 1. Now that they have the same base, you know that this is equal to 2 to the power of 2 plus 2n minus 2 minus 1, and that's equal to 2 to the power of 2n minus 1. So yeah, the rules for exponents. Anyways, this is the outline how you can do it, let's say, in a different way, by leveraging the closed form.
Yeah, Professor, there is another comment.
Yes.
Is it not working well for anyone else?
Let me look at this. I don't understand the question. Sonora, is it not working well for anyone else? I don't quite get the question. So the stream. Yeah, I'm sorry if the stream is scratchy. So there is also a stream on YouTube. So for the next recitation, I will kind of post ahead of time the YouTube stream. So you can watch it there as well. It might be a little bit better. I'm not sure. I mean, I cannot be sure about that. And the issue is that there it's much harder to ask questions. So you can totally watch it, but it's less interactive. So just in case, next time I'll post the YouTube stream link as well. Any other questions? Okay. Okay. Let's do another quick one. Okay. So let's prove this theorem using using these rules of propositional logic that you can see here below. So we did this already in the lectures, and so let's practice this. So what do we want to prove? We want to prove that the left-hand side is equivalent to the right-hand side. So this here sign that looks like you know, these 3 bars, you read this as equivalent. And so how do we typically do this? So typically we want to use these rules below to rewrite the bigger side into the smaller one. You can go in the other direction as well. You can try to grow the smaller one into the bigger one, but I find that to be much harder. I don't know, the way our brains work, it's much easier to work on shrinking something than growing. So let's try to do this. So we have the left-hand side. So we have P and Q. Oh, I apologize with my hand. And R. My handwriting will get better. Just give me a week or two, I hope. Or P and Q and not R. So that's left-hand side. So let's try to see which rules we can apply. So how does this look like? Oh, one thing that I always like to mention. So we use the letters, you know, P and Q for variables in this expression, in this formula that we are going to prove. And P and Q are also used in these rules below. Now note that this P and Q are not the same P and Q. So the way to think about these rules are as templates. And this P and Q in these rules are placeholders that you can you can match any sub-expressions in the original formula. So the original formula could have as well had, A, B, and C instead of P and Q, and you would still be able to match them against these rules. So I hope this makes sense. Okay, so let's see. So what does this kind of look like? Well, it looks like this right-hand side of the distributive rule. We have this or in between, and we have two parentheses, the left one and right one. Then in the parentheses, we need ands in both of them. So it's P and Q or P and R. So in our case, this placeholder P matches this whole expression P and Q. And then Q is R and R is not R. So we are going to apply the distributive rule. You always have to write down the name of the rule you're applying. And we are going to get the left-hand side of this rule. So P, which is in our case P and Q, and Q or R. So Q is R or not R. Okay. Now that's equivalent to, we're again looking up the rules. Which one can we apply? We can see that this expression here in parentheses, R or not R, directly matches the negation rule. So we apply negation. And we get P and Q. And this is written into just true. Great. We should keep an eye on what we are trying to get. So we want to rewrite it to get this right-hand side here. So we are quite close. We just have to get rid of this true. And so the rule we want to apply next is identity. So we apply identity. And we get just P and Q. So using these equivalence rules below, we rewrote this initial long formula into just P and Q. And that matches the right-hand side. So therefore, we now proved that the left-hand side is equivalent to the right-hand side. So that's how you do it using these rules. Okay, so we'll have to stop here because we are already running over time. Any questions about this? Or about the class in general? Know that I will post this video on YouTube, and I will post the slides with these scribbles as well, so you can go back to this.
No, there is no question.
Thank you, Lynn.
So here is a question from the chat. Can you write another version of this explanation?
I don't quite get it, Anthony. Oh, it's a little bit hard to read this. Okay, so so I'll post these scribbles and I will redo this at home and I will try to write it in a nicer way. So I'll redo it, no problem. And I'll get better at this. Sorry about my handwriting. Any other questions? Okay, so feel free to ask questions on Piazza. I encourage you to do that. You can also send me private questions there as well. If you have any kind of questions about the course, you need accommodations, anything like that. Do we have to turn in practice quiz 1? there is no, I'm not sure what, so there's pre-class quizzes and there is no pre-class quiz 1. The name of the first pre-class quiz is pre-class quiz 2. So you should start with that one. Okay. Okay. Thank you, everyone. And I'll see you in a week. Bye.